So, we begin with the topic Ionic Equilibrium. As such, there is no difference in ionic or chemical equilibrium. In fact, ionic is just another set of examples within the system of chemical equilibrium. If we have to differentiate between them, we may define the ionic equilibrium as a system in which either the reactants, product, or maybe both contain ions. Further, ions cannot exist in the gaseous phase, or the free ions cannot exist even in the solid. So ionic equilibrium essentially becomes equilibrium in solutions. Before we begin, there are certain terms that need to be made clear at the beginning itself. The first amongst them, electrolyte. The substance which dissociates into ions and conducts electricity in the molten state or in solution is termed electrolyte. In this chapter, Ionic Equilibrium, we would be restricted to dealing with only solutions, and that too aqueous. Hence, here a bit of different definition of electrolyte is used to suit our specific need. Here, the electrolyte is a substance which dissociates into ions and conducts electricity when dissolved in water. Electrolytes are all different. They differ from each other in many aspects, the most important being the extent of dissociation or ionization. Before moving any further, let's understand these terms: dissociation and ionization. Dissociation refers to the process involving separation of ions in water, which were already existing as such in the solid state of the solute. The example, sodium chloride. On the other hand, ionization corresponds to a process in which a neutral molecule splits into charged ions in the solution. For example, hydrochloric acid, hydrogen chloride. Here, in the context of ionic equilibrium, we shall not distinguish between the two and use the two terms interchangeably. By the extent of dissociation, the electrolytes are classified in two categories: strong electrolyte and weak electrolyte. Strong electrolyte, a substance which completely dissociates into ions when dissolved in water, is termed strong electrolyte. The acids which completely dissociate into ions when dissolved in water are termed strong acids. For example, hydrochloric acid. Similarly, bases like sodium hydroxide completely dissociate into ions when dissolved in water and are termed strong bases. The salts may or may not have high solubility in water, but whatever amount dissolves is completely dissociated. Hence, strong acids, strong bases, and all the salts are strong electrolytes. Weak electrolyte, a substance which dissociates only partially, that is, marginally or slightly, when dissolved in water, is termed weak electrolyte. The acids which dissociate only partially in water are termed weak acids. The example, acetic acid. Similarly, weak bases like ammonium hydroxide dissociate only partially. Water itself shows a very small dissociation into ions. Pure water is as such a bad conductor of electricity. Hence, weak acids, weak bases, and water are examples of weak electrolytes.